Hi. So today's topic is roots and irrational numbers. Our goal for today is we're going to evaluate, and don't forget, evaluate means to solve, expressions with roots. Second thing we're going to do today is we're going to classify real numbers. To classify something means to give it a name. Alright, our first vocabulary word, and I'm going to apologize first off, you do have lots of vocabulary words today, but we're going to just start off with the easy one just for now. Square root. So a square root is a number that is multiplied by itself, okay, and that again becomes a product of this. So let's look at this part right here. Square root of 9, so there's a radical symbol right here. So square root of 9 is 3 because 3 times itself is 9. So we're actually looking just for that number, that one number that's going to multiply itself to get that number, okay? That's pretty easy. Alright, so our first thing that we're going to do is we're going to go and find some roots. So here we have square root of 64. And what we need to think about is we need to think about what number times itself was going to give us 64. So if we kind of think about it, 8 times 8 gives us 64. So the root, square root of 64 is 8. Now we're not going to write this every single time. I'm just doing it just so that way you know that just one of the 8's is the square root of 64. Alright, so let's go ahead and look at it again. Well, what happens if you have a negative number? Well, the negative is actually on the outside, so you don't have to really worry about this. This basically just means you're taking the negative of whatever the answer is. So since we know that the square root of 64 is going to be 8, we're just going to go ahead and put that there. So the answer comes out to be negative 8. So if you want, just draw a little arrow, okay? Because you have to solve this part first. Square root of 64 is going to give us 8, and then you just take the negative of that 8, which gives you a negative 8. Now, there's something special right here. If you look right here, you have a 3. Notice that this one you have no little numbers here. You're always assuming that if there's no little numbers, you're always looking for the 2. So you're looking for something times itself only. Here, you're looking for what times itself 3 times. So I want you to think, what times itself 3 times is going to give you 64. If you think about 4 times itself 3 times, 1, 2, 3, that gives you 64. So the root whoops, can't say square root this time. So the cubic root, and again that's where that little 3 comes in, that cubic. So cubic root is equal to 4. Alright, now, what about this one? Well, we're looking for 3 things of the same thing that's going to be multiplied by itself. That'll give us negative 64. Well, we know that this gives us positive 64, so let's go ahead and try negative 4. Now, if you notice, I did place these negative 4 in parentheses because you are multiplying the negative 4 3 times by itself. That gives us negative 64, which is what we want. So our root is negative 4. So once again, square roots and cubic roots, you're looking for that one number that's multiplied by itself to give you that answer inside of that radical symbol. Alright, our next thing that we're going to talk about is roots of fractions. We're going to find roots of fractions. So here, again, you're going to think about what 2 numbers that when you multiply by itself is going to give you 4 and 9. So if you think about 4, 2 times 2 is going to give us that 4. And think about the 9. That would be 3. 3 times 3 is going to give us 9. Well, let's check it. That gives us 4 9s, which is what we want inside here. So our root is going to be one of those. just one of those. Okay? Alright, same deal here. Now again, don't let that negative fool you. Just put that negative on the outside. And in your head again, I want you to go ahead and think about what times itself will give us 1. That's an easy answer. 1 times 1 is 1. Now, what times itself is going to give us 16? Well, that's easy. 4, because 4 times 4 is 16. So our answer here is negative 1/4. Now, same as the other one that we just did, if you noticed, that little 3 symbol comes up again. That basically means what times itself 3 times will give us 8. So think about it again. 2 times 2 times 2 is going to give us 8. And what times itself 3 times is going to give us 125? The answer is going to be 5 times 5 times 5. So our square root here is 2/5. Alright. Now let's do a little bit of a word problem. So the area of your room is 45 feet squared. So let's go ahead and draw a room. And again, your room is square. So what we want to know is, well, let's first of all go ahead and figure this out. The area means that the entire room is 45 square feet. What are we trying to find out? We're trying to find out what the side length of your room is. So we want to know what this is, or this is, or this is, or this is. Just because, well, the thing is, it's a square, so which means if we know this, that's the same, that's the same, that's the same. So let's go ahead and think about this. Well, first of all, we're actually looking for the square root of 45. So let's write that out. So we are actually looking for this. Now, what you do notice is that, well, 45 is not a nice number. It's not like 49. So if you think about it, square root of 49 would be 7. And it's not a nice number like square root of 36, which would give us 6. However, if you look at that number, doesn't that fall between 36 and 49? So which means your answer is going to be somewhere between those two numbers. So let's just kind of guess. So we're thinking 7 times 7. Let's try that. If we do 7 times 7, that's 49. That's too big for this. So 7 doesn't work. So let's try 6. 6 times 6, that's 36. That's a little too small. So we know it's going to be somewhere between 6 and 7. But it can't go over 7. So what I can look at is, well, we can just try a couple of calculations. If we do, let's try 6.5 times 6.5. If you multiply that out, 5, 2, 3, you put the 3 right here, and then the placeholder, that's your 0. You put your 3 up there, that's 36, 39, the 3, and then you're going to have, let's see, oops. So then now you're going to have 5, 2, 12, 1, 42, and then don't forget your 2 decimal places. That's pretty close. So I'm going to say this is about 6.5 or 6.6, somewhere about there, okay? So this one you're going to have to do a little bit of guessing checking. This is just your basic type of word problem of certain numbers that are not nicely. They're not perfect squares, okay? Alright. And I did warn you from the beginning, we have more vocabulary. So these are numbers that you're really going to have to pay attention to. Natural numbers, these are your counting numbers, 1, 2, 3, 4, 5, on and on and on until a million. Those are whole numbers, okay? Now, then you have whole numbers. Now, whole numbers, you would think that this would have been counted, but whole numbers include that 0 right here. So don't forget, it includes that 0. Integers are all the whole numbers and their opposites. So it includes 0, so you have 1, its opposite, -1, 2, its opposite, -2, 3, its opposite, -3, and so on, till a million, and to -million, to and infinite. Now, rational numbers, this includes all these numbers. It includes your whole numbers, includes 0, it includes negative numbers, -1, includes fractions, includes decimals that even repeat. So you can even have a decimal that repeats 0.19, both of them repeat, that is also a rational number. The only time that you're looking at this and thinking, well, what would constitute not a rational number? Well, that'd be called an irrational number. So an irrational number would be anything like this, which is like square root of 3. Now, if you think about it, square root of 3 means what times itself is going to give you 3. The answer is nothing. There's nothing that's going to give you 3 when you multiply it by itself. Same thing here. What's the square root of 5? Nothing. Even if you put a negative in front of it, doesn't even matter. Now, pi is a symbol, and that means 3.1415, and so on and so on and so on. And it goes on forever, and it doesn't repeat. There's no pattern to it, and it doesn't end. So pi is also called an irrational number. Okay? So make sure that you know this. These couple of things right here. Pause it at this point if you need to go and write things down. Alright. So we're going to classify real numbers. Now, notice it says write all that apply. So you're going to go and write down every single thing that does apply for it. So here, 2/3. Well, number one, it's a fraction. So if you look back, well, that's a rational number. So let's go ahead and call that a rational number. Okay? And then, let me see. Is 2/3 a whole number? No. Natural number? No. Integer? No. So basically, the only thing that this one is, it is a rational number. And again, it is a real number because, well, it's part of the whole real number system. So, rational number, it's also a real number. So it falls into that larger umbrella. How about 4? Well, 4 is a natural number, so we can call it natural. It is also a whole number. It is also an integer. And it is also, of course, rational. Remember, rational kind of encompasses everything above it. So all the whole numbers, integers, and all that stuff. Now, here we talked about this already. It's a square root of 2. Is there anything that when you multiply it by itself is going to give you 2? And no, 1 times 1 is not equal to 2. 1 plus 1 is, but not 1 times 1. So this is automatically irrational. And that is how easy it is to just classify your real numbers. Okay? Now, there is one thing I wanted to go and add to this part. 2/3. As long as they are both integers, so it could be a negative 2/3, it's still a rational number. Alright, let's see if there's anything else. Nope, that's it.